to some mathematics. In this video, I'm continuing our series, or the series that I started, trigonometry. The last video that I made on this topic was compound angles. So today we are going to look at multiple angles. Let's begin. So multiple angles, right? So identities for the compound angle can be used to derive important identities for angles such as half A, 2A, 3A, and etc. These are considered as multiple angles. So first of it is double angles. So going back, compound angles, if you have sine A plus B, that is sine A cos B plus cos A sine B. So the 2A can be written as A plus A. Now the moment we see two angles, then we can apply compound angles. So that will be sine A cos A plus cos A sine A. But this is the same as sine A cos A. So when we put them together, we have 2 sine A cos A. So that is the next identity. Next will be for cos. So from our compound angles, cos A plus B is cos A cos B minus sine A sine B. So 2A can be written as A plus A. So using compound angles, we have this cos A minus sine A sine A. So that will be, this will be cos squared A minus sine squared A. That's the first part. I remember we said that sine squared A plus cos squared A is equal to 1. So we can express one of these in terms of that. So sine squared A will be 1 minus cos squared A, right? So in place of cos squared A, we put this one there. And then when we do that, we simplify. We have 1 minus sine squared A. In the same way, we replace sine squared A by this. Now when we simplify, we have 2 cos squared A minus 1. So in short, a double angle for cos 2A, you can express it in 3 ways. The first one is this, the second one is that, and then the third one. So be careful. Next one will be tan. Yes. So tan from compound angles, tan A plus B, that's as we have considered. So tan 2A will be A plus A, which is that. So when we simplify, we have tan 2A being equal to 2 tan A over 1 minus tan squared A. So let's quickly come to half angles. Remember, 1 is the same as 1 over 2 plus 1 over 2. Half plus half is equal to 1. So in the same way, we have sine A, angle A, we can write it as A on 2 plus A on 2. And these are considered as half angles. So we continue with the compound angles. Using compound angles, you get this. If you remember, double angles, we had this. So half angles too, you have the same thing, just that the angle will be half. So let's look at other ones. Yes, for the cosine, it will be the same as double angle, but then this one, the angle will be half. So as we did in the previous slides, cos A can be written as cos squared A on 2 minus sine squared A on 2, which is the same as 2 cos squared A on 2 minus 1, and 1 minus sine squared A on 2, right? So let's look at tan. The tan will also take the same shape. So when we do that, we have tan A, which is equal to 2 tan A on 2 over 1 minus tan squared A on 2. Now what we are going to do is to look at the relationship between sine, cosine, and tangent of an angle in terms of tangent of the half angle, right? We have established that tan A is equal to 2 tan a on 2 over 1 minus tan squared a on 2. So if we let t to be tan a on 2, we are going to have this. Now, you know tan is opposite over adjacent. So let's draw a triangle. So when we draw the triangle, the side the acute angle is facing the opposite, so that will be 2t. And the adjacent will be 1 minus t squared. So it will be left with the hypotenuse side by using Pythagoras theorem. So yes, when we simplify, we are getting y to be 1 plus t squared. So with this, we can find the cosine and then the sine. So sine A will be 2t over, that is the opposite over hypotenuse. So 2t over 1 plus t squared. And then cos A, that is the adjacent over the hypotenuse. So 1 minus t squared over 1 plus t squared. So anytime you are given the tangent of a half angle, you can express them in terms of the other ratios. Good. So what we are going to do is to use this concept to solve a question. So let's look at it. I have a question here. If tan theta is equal to 4 on 3 and 0 degrees is less or equal to theta less or equal to 360, we have to find, without using tables or calculator, the possible values of tan theta on 2. Okay. Now we see this guy here, tan theta on 2, right? This is tan theta on 2. You remember just here, the previous slide, we said that you can express this in terms of half angle. So if that is the case, so tan theta is equal to theta on 2 plus theta on 2, right? So using compound angles, you have theta on 2 plus theta on 2 over 1 minus theta on 2, theta on 2. Okay, so this is the same as 2 tan theta on 2 over 1 minus tan squared theta on 2. Right. So let's make theta on 2 equal to x. So this implies that tan theta will be equal to 2x over 1 minus x squared. Now you were given tan theta to be 4 on 3. So this implies that 4 on 3 is equal to 2x over 1 minus x squared. You can now cross multiply, which will be 4 times 1 minus x squared, which is equal to 6x. Now let's expand 4 minus 4x squared minus 6x. You can bring this to the left hand side. So we have minus 4x squared plus 4 minus 6x is equal to 0. We can divide through by minus 2, so that we have 2x squared minus or plus 3x minus 2 is equal to 0. We then factorize. 2 times minus 2 is given as minus 4. Then factors of minus 4, that when we add, we get positive 3. When we multiply, we get minus 4. So that will be minus 1 and then 4. So break this middle term into that. So 2x squared minus x plus 4x minus 2 is equal to 0. So bring x out, we have 2x minus 1 plus 2x minus 2x minus 1. So we have 2x minus 1, then x plus 2 is equal to 0. So 2x minus 1 is equal to 0 implies that 2x will be equal to 1. So x will be 1 on 2. So x plus 2 is equal to 0 implies that x is equal to minus 2. So in short, x is equal to minus 2 and then half. And we said that tan theta on 2 will be equal to minus 2, 1 on 2. Viewers, thank you very much for watching this video. If you like this video and you have not subscribed, just click on subscribe button. You can also turn on the notification button so that anytime I upload a new video, you'll be alerted wherever you are. Bye.